Um, Today I'm going to talk about chemical names and formulas. Um, this is section 1, naming ions. So here is our objectives. Identify the charges on monoatomic ions. Define polyatomic ions and write the names and formulas of those. And identify the two most common endings of those polyatomic ions. Before we talk about monoatomic ions, I want to have a review of ions. So, what is valence electrons? It is the electrons in the highest occupied energy level. So, let's talk about monoatomic ions. Monoatomic, mono means one. So, we are talking about ones which are single atom that either they gain or lose a few electrons. So usually they lose their valence electrons. So here's are some examples: calcium, magnesium, hydrogen. These are common monoatomic ions. So if you look at the periodic table, the ones that are going to be cations, we are going to have group 1A, 2A, and 3A. So things like hydrogen, lithium, sodium, they are metallic elements, so they tend to lose valence electrons and form cations. Then how to name them? It's pretty easy. So let's see. It's kind of like a formula. You write down their name first, and you add ion or cation. So here's an example. Sodium, right? Okay, name plus ion or cation. Name, sodium, ion or cation. So it becomes sodium ions or sodium cations. Okay, next, ions of transition metals. They form more than one cation with different ionic charges, sometimes +1, sometimes +2, so on. Before we name the ions of transition metals, we need to figure out the charge of the cations of transition metal ion. The number of electrons lost determine the charge of the cations of many transition metal ions. There are two methods to name the ions of transition metals. One is by using the Stokes system. Okay. And the other one is classical name, but I prefer to use Stokes system or stock name because it's much easier than using classical name. Stokes system, a Roman numeral in parentheses is placed after the name of the element to indicate the numeric value of the charge. Here's an example. So Cooper have +1 charge or +2 charge. For +1 charge, we call Cooper 1 ion. For Cooper with 2 charge, we call Cooper 2 ion. Next, classical name. We use a root word with different suffixes at the end of the word. So the same example. Cooper. The Cooper's ion or Cooperic ion with different charges, they read they are read in different ways. Okay, next, anion. The charge of a nonmetal ion is negative because nonmetals tend to gain electrons to form anions. The charge of any ion of a group A, nonmetals, is determined by subtracting 8 from the group number. So how to name them? The stem of the element name end in "ide". So here's an example. Fluoride, right? It came from fluorine. Fluor, the stem of the element name, add "ide". Next, polyatomic ions. Poly means more than one, so they are composed of more than one atom. See the sulfate anion consists of one sulfur atom and 4 oxygen atoms. Before we start to talk about how to name polyatomic ions, I want to tell you guys where we can find it. This is very common to see in our life, and we have it every day. It's table salt, sodium chloride, and we also have polyatomic ions in processed food like hot dog. Then how to name polyatomic ions? Of the name of polyatomic anions end in "ide" or "ate", and it's according to their charge. For example, sulfate, nitrite, and nitrate, and they have different charges. But there are also exceptions, such as ammonium and in iron, cyanide and in "ide". That's it. Thank you.